Alright, hello everybody, and today I'm going to be starting a little introduction to calculus series on my channel here, where I'll be just going over the basic concepts that you might come across when you learn calculus. So for the first video, we're going to start off with something simple. We're going to take a look at an ice cream cone. And if you have an ice cream cone, what do you need on top? Well, obviously a blob of ice cream, of course. And we're going to assume that this ice cream here is a perfect theoretical sphere. And well, if we place our ice cream on our ice cream cone, then it's going to sit on our cone, something like that. Well, let's draw up another ice cream cone now. Let's draw up an identical ice cream cone. And now what happens if we make our scoop of ice cream a little bit smaller? Well, obviously, it's going to sit a bit lower in our ice cream cone. Okay, and what happens if we make our scoop of ice cream even smaller? Well, it's going to sit even lower in our ice cream cone. And the question is, how small do I have to make my ice cream such that it can touch the bottom of the cone? Because notice that each time I make my ice cream smaller, it gets closer and closer to this point right here. So let's continue making our ice cream smaller in this picture right here. If we make it really small right here, well, the problem is we can zoom into that point and we get the same cone. So this section here is kind of like the tip of this one, and then we have the same ice cream sitting here, and we can still keep making it smaller and smaller and smaller, and we can keep zooming in and making it smaller and smaller. But until what point will it reach the very bottom of our ice cream cone? Well, the problem with that is if you think about the radius of our ice cream as a finitely small number, well, it's never going to reach the bottom of the cone because, well, we're always going to get some extra space here where we can keep shrinking it down. And of course, you may say, well, what if the radius of our ice cream is exactly 0? Well, still, the problem with that is, if the radius is 0, then we're just saying, well, our ice cream is a single point. But a point is not any three-dimensional shape or anything. It doesn't make sense because then our ice cream wouldn't really be an ice cream anymore. So even though our ice cream can't really touch the bottom of our cone, no matter how small we make it, we can think about what happens as our ice cream gets smaller and smaller and smaller. Well, it's going to get so small that the distance it is away from the tip of the cone is negligible. So you can pretty much think about this as making our ice cream smaller, then zooming in, then smaller, then zooming in, and keep on doing that for infinitely many times. And each time you do so, this gap here will be smaller and smaller and smaller, and even though it can't reach 0, it's going to be so incredibly small that we can just pretty much think about it as being 0. So this is one of the most important ideas in calculus called a limit, where something can't really get somewhere, but we can think about what happens to it as it approaches this value. So just keep that idea in mind. Even though we can't make the radius of our ice cream 0, because otherwise it wouldn't make sense, we can think about what happens as the radius approaches 0. Well, as it gets smaller and smaller, well, then our ice cream will end up where we wanted it to be, which was the bottom of the cone. So that's pretty much all for this first little video. It was just a quick one, just to kind of warm up for the following videos. But yeah, until then, I'll see everyone next time.